Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discussion of linearly, circularly and elliptically polarization. Let's begin. We know that the propagation of electromagnetic wave means that is the combination of electric field vector and magnetic field vector. These two are mutually perpendicular with each other and also perpendicular to the direction of propagation of electromagnetic waves. That is the transverse nature of electromagnetic waves. That electromagnetic wave overall we call unpolarized electromagnetic wave, and we get polarized electromagnetic wave from that of unpolarized electromagnetic wave by various methods. Some of the methods are polarization by reflection and polarization by total internal reflection. We have already discussed these two. So, we obtain polarized electromagnetic wave from that of unpolarized electromagnetic wave. So, the basic feature of that polarized electromagnetic wave is it has the component of electric field vector. The orientation of electric field vector decide either it is polarized or unpolarized electromagnetic wave. So, by taking that nature, the polarized electromagnetic wave is further classified as it is linearly polarized or circularly polarized or elliptically polarized. So, here we discuss one by one what are the natures of that particular polarized wave. So, it is called as the linearly polarized, circularly polarized or elliptically polarized. Let us come to that topic. The wave is said to be linearly polarized. In which way? A wave is said to be linearly polarized if the electric field oscillates along a straight line at any point as a function of time. The type of polarization we called plane polarized or linearly polarized wave. In coordinate system, when we represent x, y, z, z with the direction of propagation of electromagnetic wave, and then we have electric field vector. The orientation of electric field vector with respect to x axis like this, and with respect to y axis in this way. So, we can represent that electromagnetic wave as E x vector as its magnitude part, its amplitude E o x e to the power I, propagation of direction of electromagnetic wave along z direction. So, k z minus omega t plus its phase phi of x, and direction of propagation unit vector along x direction as E x cap. Equation number 1. Again, let with respect to y axis, what be the orientation of that of electric field? This is electric field vector. electric field vector that is oriented with respect to x axis. Then at y axis, with respect to y axis, E y vector is equal to its amplitude O y to e to the power I k z minus omega t plus its phase phi y, unit vector along y axis E y cap. Equation number 2. E x and E y are same phase for that of linearly polarized wave. For linear polarization, that E x vector and E y vector are in same phase, that is phi of x is equal to phi of y, let us say phi. Then E vector can be represented as E x vector plus E y vector, the superposition of two vectors, as E o x E x cap plus E o y E y cap e to the power I k z minus omega t plus phi. Equation number 3, that is linearly polarized. Which one is linearly polarized? So, the linearly polarized wave, we call it as plane polarized wave. It is the electric field oscillates along a straight line at any point as a function of time. So, either it is in x or in y, that is oriented. Next type of polarized wave is circularly polarized wave. Here is the linearly polarized wave. For circularly polarized wave, if the amplitudes of two components are equal, but their phase differs by pi by 2, amplitudes E o x is equal to E o y is equal to E 0, amplitudes are same, but the phase differs by pi by 2. Therefore, the equations E x vector is equal to E o e to the power I k z minus omega t plus phi into E x cap, and E y vector, which is the phase differ by pi by 2. So, the amplitudes are same, E naught e to the power I k z minus omega t plus phi plus minus pi by 2 into E y cap, that phase difference of pi by 2. Next, here we taken it as phi of x as phi and phi of y is equal to phi of x plus minus pi by 2. So, it is phi plus minus pi by 2 we used here. Then we considering the real part, considering the real part, e to the power I theta, that is cos theta plus I sin theta. So, cos theta is the real part and sin theta for that of imaginary part. As we considering the real part, so e to the power that factor is taken as cos of this. So, E x is equal to E o cos k z minus omega t plus phi. Next, for E y, that is E naught into e to the power I something. Look here, the real part is cos of k z minus omega t plus pi plus minus pi by 2, cos of pi by 2 plus theta, that is sin theta. Therefore, we write for E y as E naught sin k z minus omega t plus phi as cos of pi by 2 plus theta as sin theta. Equation number I, equation number II. So, squaring we have E x square plus E y square. So, E naught square cos square that one plus E naught square sin square that one, E naught square as common, sin square theta plus cos square theta 1, and finally dividing E naught square on both sides. So, we obtain E x square divided by E naught square plus E y square divided by E naught square is equal to 1. I just write it directly. You have to square and then adding these two equations and dividing E naught square, then we obtain that one. Look careful to that of equation. That equation nothing but the equation of a circle. Which represents equation of circle, so that the resultant electric field, traces out a circle, with frequency omega. Such a wave is said to be circularly polarized. Look here, in the graphical form, if we consider that is x axis, y axis, and direction of propagation of that wave along that of z axis. So, at that of time that electric field is varying just like a circle. At this time that electric field is varying in clockwise direction. That type of polarization we call left-handed circularly polarized wave. Left-handed circularly polarized wave. Polarized wave. That the electric field vector has a constant magnitude E naught and is a function of time only, and changes its direction in a continuous manner. If that rotation is anticlockwise, if that rotation is anticlockwise, rotation here we taken as clockwise. If it is anticlockwise, then it is called left-handed circularly polarized. Means when one observer is facing into coming that of wave, then it is said to be left-handed circularly polarized, or we call it as positive helicity. On the same one, when we taken it x, y, z, that is in clockwise direction, then it is called right-handed circularly polarized, right-handed circularly polarized wave. So, that is the basics of circularly polarized wave. The amplitudes are equal, but their phase differs by pi by 2. Here the rotation of electric field is clockwise, and that wave is called right-handed circularly polarized, and we call it as negative helicity. This one as positive helicity, that one as negative helicity, Next type of polarization, elliptically polarized wave. If the amplitudes of two components are unequal, but their phase differs by pi by 2. Here the amplitudes are equal, but phase difference is pi by 2, then it is called circularly polarized. If the amplitudes are different, but the phase differs by pi by 2, then we obtain an elliptically polarized wave. How? Mathematically we can show it. Then its amplitude is not equal to with another amplitude, but phase differed by pi by 2, whereas we taken it as that phi x is equal to phi. So the components of electric field, Ex vector is equal to Eox e to the power I kz minus omega t plus phi into Ex cap. Next, for Ey vector, it is Eoy into e to the power I kz minus omega t plus minus pi by 2 plus that is plus phi plus minus pi by 2 into E y cap. Here the phase differed by pi by 2. Now considering the real part, let us considering the real part in that of previous manner. We take the real part. So the real parts are taken as Ex is equal to Eox cos kz minus omega t plus phi. Next, Ey is equal to, here cos of pi by 2 plus theta is this, but in that of situation it is minus plus Eoy sin kz minus omega t plus phi. Therefore, we have Ex divided by Eox, which is equal to cos kz minus omega t plus phi, and Ey divided by Eoy is equal to minus plus sin kz minus omega t plus phi. Therefore, squaring on these two equations and adding it, so Ox square plus Ey square divided by Eoy square is equal to 1. This is the equation for an ellipse, which is the equation of ellipse, which is equation of an ellipse. So the resultant wave is said to be elliptically polarized wave. Elliptically polarized wave, as the resultant electric field that resultant electric field vector traces out an ellipse. How? Look here, if we plot it in that of graph x, y, this is the propagation of electromagnetic wave in that of z direction, and we show it with respect to time. So the amplitudes of that of electric field vector gradually changed with respect to time, and it is oriented by the phase difference of pi by 2. That's why we obtain an ellipse, and that type of polarization of electric field vector is called elliptically polarized wave. Like that of previous one, either if it is anti-clockwise, then it is called left-handed elliptically polarized wave. If it is clockwise, then it is called right-handed elliptically polarized wave. So here with the help of this video lecture, we understand various types of polarization as linearly polarized wave, Here we show what is linearly polarized wave. Then circularly polarized wave, it has the amplitudes of the components are equal, but the phase differs by pi by 2. Next, elliptically polarized wave, the components are unequal, the amplitudes of the two components are unequal, but their phase difference also pi by 2, and we mathematically show it. So with this useful and informative notes, let me wind up the session. Thank you.